Good morning, students. I am Savita, Associate Professor in Mathematics. In this video, I am going to discuss elementary transformations of a matrix, using which we find the rank of the matrix. This video is useful for 5th semester BSc students of Mangalore University. Now let us begin with elementary transformations of a matrix. Now, in order to find the rank of a matrix, we require the definition of minor of a matrix and the definition of rank of a matrix. Now, what is a minor of a matrix? The determinant formed by selecting any R rows and R columns from any matrix A and deleting all other rows and columns is called minor of A of order R. Now, what is the definition of rank of a matrix? A matrix is said to be rank R when it has at least one non-zero minor of order R and every minor of order greater than R vanishes. Minor is obtained by deleting rows and columns of any matrix. Okay, deleting the rows and columns, we get minor of the matrix of order R. Okay, and the rank of the matrix is defined as R if it has at least one non-zero minor of order R and every minor of order greater than R vanishes. Now let us understand elementary transformations of a matrix. There are three following operations which are known as elementary transformations or elementary operations. If the operations are performed on rows, these operations are known as elementary row operations. If the operations are performed on columns of a matrix, these operations are known as elementary column operations. The first row operation is interchange of any two rows. That is, you interchange any two rows of a matrix. If you interchange any two columns, then it is called column operation. The multiplication of any row by a non-zero scalar, by a non-zero number, that is the second elementary row operation. The third row operation is multiply the elements of any row by a non-zero number and add the corresponding elements to another row. Add the elements to the corresponding elements of another row. That is, the addition of a constant multiple of the elements of any row to the corresponding elements of another row. So these three operations are known as row operations. If the operations are performed on columns, then these operations are known as column operations. Okay. So for example, you can interchange R1 and R2, that is first and the second row. Okay. Or you can multiply any row by a non-zero number. For example, you multiply the elements of the second row by 2. That means multiplication of any row by a non-zero number. The addition of constant multiple of the elements of any row to the corresponding elements of any other row. That is, if you are multiplying third row elements by 3 and adding those elements to the corresponding elements of the second row, then it is the third elementary transformation. Okay. Now these transformations are denoted by the following symbols. First symbol is R suffix I j. Capital R stands for row, I stands for ith row and j stands for jth row. So R suffix I j stands for the interchange of ith and jth rows. Second row operation is denoted by k into ri. K into R suffix I, that is, ith row elements are multiplied by k. That is, multiplication of the ith row by k, where k is a non-zero number. Third row operation is denoted by r suffix I plus p times r suffix j. That is, jth row elements are multiplied by p and they are added to the corresponding elements of ith row, which means addition to the ith row p times the jth row. So these are the notations used for row transformations or row operations. So if you perform operations on columns, then symbols used are C, I, J, K into Ci or Ci plus P times Cj. Okay, instead of R, C anta bardre aitu. R stands for row and C stands for column. Now these elementary transformations do not change the order or rank of a matrix, while the value of the minus may get changed by the transformations, by the above transformations 1 and 2. Now let us understand equivalent matrix. Two matrices A and B are said to be equivalent if one is obtained from the other matrix by a sequence of elementary transformations. And the symbol for this equivalent matrix is this. Okay, two equivalent matrices have the same order and the same rank, and this is a symbol used for equivalence. You can see on your screen. This means the two matrices are equivalent. So on performing elementary row transformations or column transformations, we can say that the two matrices are equivalent. Okay. Now, definition of elementary matrix is: an elementary matrix is that which is obtained from unit matrix by subjecting it to any of the elementary transformations. I hope it is clear. Now let us determine the rank of the given matrix. The matrix is 3 cross 3 matrix. First row elements are 1, 2, 3, 1, 4, 2, 2, 6, 5. ಹೇಗೆ ರ್ಯಾಂಕ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದು? ಯೂಸಿಂಗ್ ಎಲಿಮೆಂಟ್ರಿ ಟ್ರಾನ್ಸ್ಫರ್ಮೇಷನ್ಸ್. ನಾವಿಲ್ಲಿ ರೋ ಟ್ರಾನ್ಸ್ಫರ್ಮೇಷನ್ಸ್ ಯೂಸ್ ಮಾಡುವ. ಆದಷ್ಟು ರೋಸ್ 0 ಮಾಡಲಿಕ್ಕೆ ಟ್ರೈ ಮಾಡಬೇಕು. ಅಂದರೆ ಮೈನರ್ ಸಿಗ್ತದ. ಮೈನರ್ ಆಫ್ ಆರ್ಡರ್ 3 ಆದರೆ ರ್ಯಾಂಕ್ ಆಫ್ ದ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇಸ್ 3, ಬಿಕಾಸ್ ನಾನ್ ಝೀರೋ ಆದರೆ ರ್ಯಾಂಕ್ ಆಫ್ ದ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇಸ್ 3. If you find a non-zero minor of order 2, then rank is equal to 2. Otherwise, rank is equal to 1. Okay. So, since this is a matrix of order 3, rank 3 agirbodu, 2 agirbodu, athava 1. It cannot be greater than 3. Now, let me use elementary row operations. First row operation is R2 minus R1. Illi 1 ide, illi sa 1 ide. First row dalli element 1 ide, second row dalli sa element 1 ide. So R2 minus R1 madidre ee element 0 agtade. So first row operation is R2 minus R1. So we have 1 minus 1, that is 0, 4 minus 2, 2, 2 minus 3, it is equal to minus 1. So the given matrix is equivalent to 1, 2, 3, 0, 2, minus 1. Okay. The next row operation is R3 minus 2 R1. Why it is R3 minus 2 R1? So this element is equal to 1. The first element in the first row is equal to 1. ಈಗ ಈ ಎಲಿಮೆಂಟ್ ಅನ್ನು 0 ಮಾಡಬೇಕಾದ್ರೆ ಫಸ್ಟ್ ರೋ ಅನ್ನು 2 ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ಆಮೇಲೆ R3 ಇಂದ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡಿ. ಸೊ ನಾವು ಸೆಕೆಂಡ್ ಎಲಿಮೆಂಟರಿ ರೋ ಆಪರೇಷನ್ ಯೂಸ್ ಮಾಡ್ತೇವೆ. ಯು ಆರ್ ಮಲ್ಟಿಪ್ಲೈಯಿಂಗ್ ದ ಫಸ್ಟ್ ರೋ ಬೈ 2 ಆ್ಯಂಡ್ ಯು ಆರ್ ಸಬ್ಟ್ರಾಕ್ಟಿಂಗ್ ಇಟ್ ಫ್ರಮ್ ಥರ್ಡ್ ರೋ. Therefore, elementary row operations ಅಲ್ಲಿ ಸೆಕೆಂಡ್ ಮತ್ತು ಥರ್ಡ್ ಕಂಡೀಷನ್ಸ್ ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತೇವೆ ಒಟ್ಟಿಗೆ. R3 minus 2 R1. So we have 2 minus 2 is equal to 0. This element is multiplied by 2. So this is 4 now. 6 minus 4 is equal to 2. 5 minus 6 is equal to minus 1. Now look at this matrix. Two rows are identical, isn't it? So determinant evaluate ಮಾಡುವಾಗ ನಮಗೆ ಎರಡು ರೋಸ್ ಐಡೆಂಟಿಕಲ್ ಇದ್ದರೆ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದ ಡಿಟರ್ಮಿನೆಂಟ್ ಇಸ್ ಈಕ್ವಲ್ ಟು 0. Therefore, third order minor of A vanishes, isn't it? Since two rows are identical, third order of A, let us denote this matrix by A. So this minor or minor of order 3 vanishes. Therefore, rank of the matrix cannot be equal to 3. Okay, now how to make this element 0? ಈಗ ಇದನ್ನು 0 ಮಾಡಲಿಕ್ಕೆ ಸುಲಭ ಇದೆ. 0 ಮಾಡಬೇಕಾಗಿ ಇಲ್ಲ. ನಿಮಗೆ ಮಾಡಬೇಕಂತ ಹೇಳಿದರೆ R3 ಮೈನಸ್ R2 ಮಾಡಿದರೆ ಈ ರೋ 0 ಆಗ್ತದೆ, ಅಥವಾ ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ಮೈನಸ್ 0 ಆಗ್ತದೆ. ಸೊ ಒಂದು ಸೆಕೆಂಡ್ ಆರ್ಡರ್ ಮೈನರ್ ನಾನ್ ಝೀರೋ ಸಿಗುತ್ತೆ. ಅದು ಯಾವುದು ಹೇಳಿದರೆ 1 2 0 2 ಕನ್ಸಿಡರ್ ಮಾಡಿದರೆ ವಿ ಗೆಟ್ 1 into 2 2 minus 0 which is non-zero, ಅಥವಾ 1 3 0 minus 1 that is also non-zero minor which is of order 2. Therefore, minor of order 3 is 0. Second order minor formed by second and third rows are also 0. But we find another second order minor, say 1 3 0 minus 1 which is equal to minus 1. The value of this minor is 0 1 3 0 minus 1 is equal to minus 1 which is non-zero. So we have a non-zero minor of order 2. Therefore, rank of the matrix is equal to 2. I hope it is clear. Now let us find the rank of this matrix. Determine the rank of the matrix. Now this matrix is a 4 cross 4 matrix. There are 4 columns and 4 rows. Okay. So elements are 0, 1, minus 3, minus 1. Second row elements are 1, 0, 1, 1, 3, 1, 0, 2, 1, 1, minus 2, 0. Okay. Use elementary row operations or column operations and find the rank of the matrix. Okay. So let me use column operations here. ಇಲ್ಲಿ column operations use ಮಾಡಿದ್ದೇನೆ. ನಾನು ಇದೇ ಆಪರೇಷನ್ಸ್ ಯೂಸ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳ್ತಾ ಇಲ್ಲ. ನೀವು ರೋ ಆಪರೇಷನ್ಸ್ ಯೂಸ್ ಮಾಡ್ಬೋದು. ಮಾಡಿ ಮೈನಸ್ ಆಫ್ ಆರ್ಡರ್ 4 0 ಮಾಡಲಿಕ್ಕೆ ಆಗ್ತದ ನೋಡಿ. ಮೈನರ್ ಆಫ್ ಆರ್ಡರ್ 4 0 ಆದರೆ ಮೈನರ್ ಆಫ್ ಆರ್ಡರ್ 3 0 ಆಗ್ತದೆ ನೋಡಿ. ಇಫ್ ಮೈನರ್ ಆಫ್ ಆರ್ಡರ್ 3 is not equal to 0, then rank of the matrix is equal to 3. Suppose minor of order 4 is equal to 0, minor of order 3 is equal to 0 ಆದರೆ you find at least one non-zero minor of order 2. Then rank of the matrix is equal to 2, otherwise rank is equal to 1. Okay. Here let me consider C3 minus C1. C3 andre this column, C3 minus C1. So e element 0 ಆಗ್ತದೆ. Okay. Minus 3 minus 0 that is minus 3. 1 minus 1 ಇದು 0 ಆಯಿತು. 0 minus 3 that is minus 3. Minus 2 minus 1 which is equal to minus 3. Now so this given matrix is equivalent to the matrix 0 1 minus 3 1 0 0 3 1 minus 3 1 1 minus 3 ಇಲ್ಲಿವರೆಗೆ ಸೇಮ್ ಸಿಕ್ಕಿತು ನಮಗೆ. ಆಮೇಲೆ C4 minus C1 ಮಾಡಿ. C4 minus C1 ಮಾಡಿದರೆ ಈ ಎಲಿಮೆಂಟ್ 0 ಆಗ್ತದೆ. ಸೊ minus 1 minus 0 that is minus 1. 1 minus 1 0. 2 minus 3 minus 1. 0 minus 1 that is minus 1. Okay. So elementary column operations are C3 minus C1 and C4 minus C1. Therefore, the given matrix is equivalent to this matrix. Okay. Now look at the elements. Illi 1 minus 3 minus 1 ಇದೆ. ಇಲ್ಲಿ ಸಹ 1 minus 3 minus 1 ಇದೆ. ಇಲ್ಲಿ ಸಹ 1 minus 3 minus 1 ಇದೆ. So 0 ಮಾಡಲಿಕ್ಕೆ ಸುಲಭ ಇದೆ. So next operation is row operations. R3 minus R1 and R4 minus R1. R3 minus R1 ಉಳಿದದ್ದು ಸೇಮ್ ಇಡಿ. ಫಸ್ಟ್ ರೋ ಆಸ್ ಇಟ್ ಇಸ್, ಫಸ್ಟ್ ರೋ ಎಲಿಮೆಂಟ್ಸ್ ಹಾಗೆ ಬರೀಲಿಕ್ಕೆ. ಸೊ 0 1 minus 3 minus 1. ಸೆಕೆಂಡ್ ರೋ ಸಹ ಹಾಗೆ 1 0 0. ಇದರಲ್ಲಿ 0 ಎಲಿಮೆಂಟ್ಸ್ ಜಾಸ್ತಿ ಇದೆ. ನೆಕ್ಸ್ಟ್ ರೋ ಆಪರೇಷನ್ ಇಸ್ R3 minus R1 which gives 3 minus 0 is 3. 1 minus 1 0. minus 3 plus 3 0. minus 1 plus 1 0. ಸೊ ಇದು 0 ಆಯಿತು. ನೆಕ್ಸ್ಟ್ R4 minus R1 ಮಾಡಿದಾಗ 1 minus 0 1. 1 minus 1 0. minus 3 plus 3 0. minus 1 plus 1 0. Okay. So this matrix is equivalent to the matrix 0 1 minus 3 minus 1 1 3 1. Right. Okay. Now ಇದು ಎಲಿಮೆಂಟ್ 0 ಮಾಡ್ಬೋದು, ಯಾಕಂದರೆ ಇಲ್ಲಿ 1 ಇದೆ, ಇಲ್ಲಿ 1 ಇದೆ. ಸೊ ಇದು 0 ಮಾಡಲಿಕ್ಕೆ ಸುಲಭ ಇದೆ. ಸಿಮಿಲರ್ಲಿ ಈ ಎಲಿಮೆಂಟ್ಸ್ 0 ಮಾಡ್ಬೋದು. ಕರೆಕ್ಟ್. ಸಿಮಿಲರ್ಲಿ there is 1 and there is minus 1 and this element can also be made 0. So the next operation is R3 minus 3R2. Let us go back. R3 minus 3R2. If I multiply R2 by 3 and subtract it from R3, then this is 0, isn't it? R3 minus 3R2 ಮಾಡಿದ್ರೆ ಇದು 0 ಆಗ್ತದೆ. ಉಳಿದ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ ಹಾಗೆ ಇರ್ತದೆ. ಯಾಕಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ ಸಹ 0 ಇದೆ, ಇಲ್ಲಿ ಸಹ 0 ಇದೆ. So multiply R2 by 3 and subtract it from R3. So this element is 0. And the next operation is R4 minus R2. R4 minus R2 ಮಾಡಿದಾಗ ಈ ಎಲಿಮೆಂಟ್ 0 ಆಗ್ತದೆ. Therefore, next set of operations R3 minus 3R2 and R4 minus R2. So ಎರಡು rows 0 ಸಿಕ್ಕಿತು. ಮತ್ತೆ first row elements ಹಾಗೆ ಇದೆ, second row elements ಸಹ ಹಾಗೆ ಇದೆ. Now C3 plus 3C2. Since this is negative, multiply the second column by 3 and add. So minus 3, C3 plus 3C2, C3 plus 3C2, that is minus 3 plus 3, so this is equal to 0, and C4 plus C2, C4 is minus 1 plus 1, which is equal to 0. So we have a matrix 0, 1, 0, 0, 1, 0, 0, 0, 0, 0, 0, 0, and 0, 0, 0, 0. Now observe this matrix. Minor of order 4 is clearly equal to 0, isn't it? Let us denote the matrix by A. Minor of order 4 is 0. Similarly, minor of order 3 is also 0. Namge ಒಂದು minor of order 2 ಸಿಗ್ತದೆ. Look at this. You consider minor of order 2, 0, 1, 1, 0. Evaluate this, its value is equal to minus 1. This is the only non-zero minor of order 2. Since minor of order 4 is 0, rank of the matrix is not equal to 4. Minor of order 3 is equal to 0, rank of the matrix is not equal to 3. Since there is only one non-zero minor of order 2, that is 0, 1, 1, 0, whose value is equal to minus 1, which is not equal to 0. The rank of the matrix is equal to 2. So obviously, the fourth order minor of A is 0. Every third order minor of A is also 0. But of all the second order minors, only minor 0, 1, 1, 0 is equal to minus 1, which is not equal to 0. Hence, rank of A is equal to 2. I hope it is clear. So, given a matrix of order 4, rank of the matrix is equal to 2. So, we have used elementary row operations or elementary transformations to find the rank of the matrix. I shall stop here. Textbook for reference is Dr. B.S. Grewal, Numerical Methods in Engineering and Science with Programs in C and C++. Okay. Thank you.